Welcome to the video for 2.77 solving equations in one variable. I will be able to solve equations involving fractions. So, rational equations. So a rational equation is just an equation with a function over another function. And this has to be when g of x does not equal 0, because that would make it undefined. And then an extraneous solution is a found solution that's not a valid solution. So when we have a rational equation, the denominator can't be 0. So if we find a solution that would make the denominator 0, that would be an extraneous solution. Okay, find the LCD of all the terms in the equation. So this is how we're going to solve rational equations. Multiply each side of the equation by the lowest common denominator, solve the remaining equation, make sure each solution is an element of the original domain. So let's start with an easy one like this. So in this case, in order to add these fractions, the easiest way to do this is to get rid of the fractions. And as far as the domain, since we have numbers in the denominator on both of the fractions, we're fine. The domain is all real numbers, so we don't have to worry about extraneous solutions on this one. So what we're going to do is we're going to find the LCD, and my LCD is 15, and now I'm just going to multiply the whole equation by 15. So you can either distribute this out and then reduce, so you could go 15x all over 3 plus 15x all over 5 equals 60. And then you would divide this in, and you would see that 3 goes into 15 5 times, so 5x. And 5 goes into 15 3 times, and we have 60. But a little bit of a shortcut, especially when we get down to problems that look like this, is to just realize that the denominator is going to just go into this number, and what comes out is going to go and multiply by the numerator. Okay, so just forgetting about this step for a moment, 3 goes into 15 5 times, then I just do 5 times x. 5 goes into 15 3 times, so I just get 3 times x, and that's going to make these a little bit easier. So now I'm just going to combine like terms. And x equals 7.5. Okay, coming over here, I'm looking for the LCD. Well, the LCD, since I only have one denominator here, is going to be x minus 6. But let's look for extraneous solutions really quick. So if I end up with a solution that is 6, we can't have 6. So x cannot equal 6. So if I do all my work and find out that one of the solutions is 6, that would not actually be a solution to this equation. Okay, so I'm going to multiply all of it times 8 minus 6. And for this first one, there's no denominator, so the whole 8 minus 6 is going to be multiplied by the x. So we have x times 8 minus 6. Then we have minus, and then this is going to go into here 1 time, and 1 times 7 is 7. And then lastly, 0 times x minus 6 is 0. Now I just need to distribute, and I get x squared minus 6x minus 7 equals 0, and I have a quadratic, so it's time to choose which way I'd like to solve this. If I can quickly look and see if there's a number that will multiply to this and add to this, then I know it's going to be factorable. So when I look at negative 7, 7 times 1 is 7, and 7 minus 1 is 6. So I'm pretty sure it's going to factor. I didn't think about my negatives yet, but I'm going to go ahead and go for it and see what happens. So 7 and 1, and then if I make this one negative and this one positive, they are going to add to a negative 6 there, and they are going to multiply to a negative 7. All right, so I have two solutions. I have x equals 7, and I also have x equals negative 1. Neither of these is 6, so neither of these is an extraneous solution. Okay, how about this one? All right, so a lot of times with these, to find the LCD, you're going to want to factor. You want to factor this because it could turn out, instead of multiplying all these together to find the LCD, just to look at one of these, basically the LCD was the denominators multiplied together. it could potentially save us some time rather than multiplying all them together if these factors here are these binomials here. All right, so I'm going to factor this out and see what I get. So x, and then I have 9, and I do have -5. And what do you know? It does match. I have to write that a little bit clearer. Okay, so that means that our LCD can just be the quantity of x plus 9 times the quantity of x minus 5. So I'm going to take my whole equation here, and I'm going to multiply it by the LCD that I just found. Just like that, and make sure you hit every single term. Okay, so right here, x plus 9 would go into this and get rid of that, so they would cross cancel, and I would just be left with x minus 5. So 2x times x minus 5, just like that. Then I have minus, x minus 5 is going to cross cancel with this, x minus 5, and so I'm left with x plus 9. So I would have 3 times x plus 9. And then lastly here, don't forget your negative. Both of these are going to go into both of these. These would cross cancel to 1. 1 times 42 would just be 42. And now I've gotten rid of all those crazy fractions, and I can simplify and solve. So 2x squared minus 10x minus 3x minus 27 equals -42. I see that I have a quadratic, so I'm going to have to get everything to the same side and then either factor or use the quadratic formula. So 2x squared minus 13x plus 15 equals 0. Okay, again, I think this is factorable. Oh, you know what we forgot to do, or I forgot to do, no one's here with me, is find the extraneous solutions here. So x cannot equal -9, and x also cannot equal 5. So let's see if we're going to get any extraneous solutions here. Okay, so we need to solve this, and I'm going to factor it. So you can use whatever method you like. I'm going to show you two methods again here. But if you don't know how to factor, you should really get in here. This factoring is not going to go away. You're going to have to be able to factor, even if you can use the quadratic equation, because as you can see up here, using the quadratic, I guess you could use the quadratic equation technically. That's certainly a long way around to be able to factor this and find the LCD. All right, so coming down here, this is the method I use. I see a times c at the top, multiply them together, and then I see that -13 is in the middle, so I'm going to put that in the bottom. And then I'm just going to come up with factors of 30 and see if they will subtract or add to -13. So 15 times 2 does multiply to 30. If I make one of them negative, I could make it so I subtract to 13. However, 2 times -15 isn't going to give me positive 30. So I'm going to have to keep looking. Okay, the next one I can think of is 10 and 3. So 10 and 3 would multiply to 30, and would they add or subtract to -13? Well, they would if I make them both negative. So there we go. And then from here, you can do one of two things. You can group, or you can use the box method. And since this video is fairly short, I'm going to show you both of them again. If you're feeling comfortable with factoring, you could probably skip and just factor it yourself and then make sure that you come up with the same answer. So you can either do this by grouping, and grouping means that you split the middle term. So here are the numbers that we've chosen, just like this. And now I'm going to use these numbers to split the middle term. So I'm going to rewrite the middle term with -10x and -3x, and then put my constant back on there. And then I'm just going to group them up. So like this and like this. And what can I pull out of both of these? Well, I can pull out a 2x, which would leave x minus 5 inside the parentheses. And here I can pull out a -3, which would leave an x minus 5 in the parentheses. And now this is a binomial. It's a big fat binomial. But I have 2x times this and then 3 times this, which means I can pull these binomials out of this bigger binomial. So I'd have x minus 5 that I'm going to pull out of both of them, and that leaves me with 2x minus 3. Okay, so I factored it. I'm going to show you now quickly the box method again for those of you who need a refresher. But the box method is just splitting the middle terms but putting it into boxes. Okay, so in this box is always going to go your first term, in this box go your last term, and in these two boxes you're splitting your middle term. So you would have negative 10x and negative 3x. And then you would just have to pull out here, well, what comes out of 10 and 15 would give me a 5, and the sign comes from the box nearest to where you factored out. So you're going to factor out this way, and then because this is a negative, this can become a negative 5. And I'm going to factor out this way. I can pull an x out of both of them. Since this term is positive, this term will be positive. Then I'm going to factor up. I can pull a 2x out of both of them. Since this is positive, this will be positive. And then lastly, I'm going to pull a 3. And since this one's negative, this is going to be negative. And then you can see how I'm just going to actually write them as in the factored form like this. Okay, so now let's find those solutions. So a whole bunch of mess over here. I'm going to come back over here, and I have x equals, well, here 5, so x equals 5. And then for this one, I would set this to 0, and this would be a positive 3/2. Okay, so looking back up at our extraneous solutions, or looking back up to our domain rather, and what we cannot include, that makes x equals 5 an extraneous solution. So we're not even going to count that one. So we only have one solution to this big rational equation. Okay, if we look at this graph, you can see that in the blue, so I'm just seeing where they're equal. So I set the two sides of the equations equal to each other. In the blue is this equation, and the red is the other. And you can see that we do have a solution at 1.5. And then at 5, well, there's a vertical asymptote. So you can see why that is not a solution here. Right, so as I zoom out, there's nothing at 5 for either of the equations. All right, be sure to try the one I've left for you, and I will see you in class.